So the life cycle. At 80 degrees, it takes about 1 month to complete a life cycle. And at 64 degrees, it takes about 4 months. So there's a huge disparity there. And temperature, insects are cold-blooded, right? So temperature has a major effect on the rate at which they develop. So let's take a temperature in between. How about 70 degrees? That's probably where most indoor environments are, 65 to 70. I keep my house at 60, so I'm trying to slow down development if I can. Anyway, at about 70 degrees, it takes about 6 weeks for those bed bugs to reach sexual maturity. So we'll see that lag time take effect in the population growth that I'll show you in a few minutes. One thing is they must feed between each life stage. So they hatch, they come out, they're pretty ravenous, they'll feed on you, and then they'll molt. And I think the way insects molt and grow is pretty neat because it's completely opposite of how we do it. But they release some hormones inside their body, and it kind of softens their exoskeleton, and it causes it to crack right down the back. And then that soft body on the inside, basically they take a deep inhale and expand their body like that, and then the air hardens the exoskeleton. And just like that, they've grown. So they do that 5 times. They have to feed in between each stage, and then finally they reach adulthood. They have to feed on human blood to be able to reproduce. So that's a key factor. Yeah. I mean, in general, they like to feed once a week. I don't know specifically like how long a blood reserve lasts for the purpose of laying eggs. I don't know. Yeah. They could lay eggs indefinitely. I mean, insects are a little bit different than humans in that when the sperm is injected, they're actually able to store all of the sperm cells. So they can indefinitely fertilize eggs as they're laying. So just a neat thing about insects. Okay, and so the eggs, so after they've mated, and the mating in bed bugs is pretty interesting because they don't do it the normal way. Actually, the way they do it is the male runs up, flips over the female, and then just pierces her abdomen. Just goes right through the body wall. And they call that traumatic insemination. And actually, over time, the females have developed a little sac that's underneath her abdomen. It's like on the 7th sternite or something, but they have a sac right underneath of there. The sperm is injected into that sac, and then there are tubes that go down to the ovaries. So the sperm is stored in here and transferred down to there. So pretty neat. They don't know why that has evolved. It has evolved in a few different insect species, but yeah, traumatic insemination. Pretty interesting. Anyway, so after they mate, 3 to 6 days, the female can start laying eggs. They lay from 5 to 7 eggs a week. So over a lifetime of over a year, one female could produce, around 500 eggs. So you can see how, as we say, fecund they are. But yeah, one female can lay a lot of eggs. So if you miss one fertilized female, this is the situation you're dealing with. So there are always caveats to bed bug biology. And for the most part, they like to lay their eggs in clusters, and they like to stay in groups. But they can also just drop eggs as they're walking around the room. So if you see a cluster and you treat it, that doesn't mean you've gotten everything. And if you see a group of bed bugs and you treat those, that doesn't mean you have everything. Because there could be one lone bed bug, somewhere else in the room. So that's one reason they're kind of bad. And this is really critical here, that the eggs take 7 to 10 days to hatch. Because a lot of the insecticides we have don't kill eggs. So if somebody comes in and treats with an insecticide, they might be able to treat all the immature and adult stages, but in most cases, the eggs are still alive. So if it takes 7 to 10 days for those eggs to hatch, that means somebody has to come back in 2 weeks, do another inspection, and do another treatment. So when selecting a pest control company, you're looking for at least a minimum of 2 treatments, if not 3, and some people take months. 2 weeks apart. Yep, that's the standard. About 6 weeks at 70 degrees. So, yeah. So, I mean, only the eggs that are there are going to hatch. It's going to take a while before they're able to reproduce. So, you have some time in that respect. And then the other thing, whenever the female lays the egg, there's this little secretion around the egg that's kind of like glue or cement. So they can pretty much stick their eggs on any surface. They do prefer to lay their eggs on cloth, so especially mattresses and beds and couches, or along baseboards. They like the surfaces of roughened wood. So if you have like like one of those particle board dressers, If you look at the back of that, the wood is all roughened on the edges. They like to lay eggs in there. Or they can lay eggs in staple holes. So right in there, all prime places. Oh, and that said, reverse not working. Okay. That said, they can lay eggs anywhere they please. So if they're running out of space along the baseboards, they could lay them in the popcorn ceiling right above your bed. So anywhere. They could lay eggs anywhere. Okay, so here's this population curve that I was talking about. And my math skills aren't that strong, so this took me a long time to do. And I'm pretty sure it's close to accurate. But you'll get the general idea of this. And so what this shows is I'm starting with one fertilized female. And it's laying about 6 eggs per week. And every egg that hatches, one of them is male and one of them is female. And it takes about 6 weeks for that egg or that bed bug to reach sexual maturity. So you can see there's kind of this lag in population growth at the start. So within about 4 to 5 weeks, you might only get an additional 5 bed bugs a week or something like that. So if you can catch it quick, in low population levels, the bed bugs tend to stick together in one spot. So if you can find them early, usually you can treat that one cluster and be done with it. But if you wait, if you don't have a good early detection program and you don't catch things until they get out here, there's a huge difference. Now you have this population that is just growing at an exponential rate. So keep that in mind. Catch them early. That's most critical. Any questions on that curve? Okay. So how do they find a host? They have this random searching, and that's basically they come out of their hiding spots at night, actually in the early morning. They love to feed in early morning because people are in a deeper sleep that time of day, so they're less likely to move and wake up during feeding. So they've actually evolved to feed kind of in late morning, or early morning, I should say. So anyway, they come out of their hiding spots, their antennae are going, and what they're picking up on is our breath, so carbon dioxide. They're picking up on chemicals that are coming off our skin, and they're also picking up on our body heat. So these 3 things. So they walk around, they're looking for these gradients of chemicals in the air and heat, and they eventually find us, and they crawl up onto us, and then they search around for a nice blood vessel, and they go ahead and insert their mouth part. And you can see that the mouth part on bed bugs is like a straw, right? So it's almost just like a mosquito. It has this straw with 2 tubes going down, and out of the one tube you have an anesthetic and an anticoagulant. So they kind of numb the skin. That's nice of them, right? I mean, these are really nice bugs. So they'll numb the area, and then they'll put a little anticoagulant in there to thin out the blood, and then through the other tube they suck up the thin blood. So that's how they do. And they prefer to feed about once a week, give or take. $5. What's that?
Do they need $5 for the plasma kit?
They make a lot of money. Anyway. But yeah, so that's how this mouth part works. And feeding in general takes about 5 to 15 minutes on average. Again, these are nocturnal. They prefer to feed at night, but that's not to say they won't feed, at midday. If you have a population on your couch and they haven't fed on you in a while, and you go to watch TV at 3 in the afternoon, they're going to come out and feed on you. So they prefer to feed at night, but they will feed during the day. And so here's kind of the course of how these things grow as they're feeding. You can see that their body kind of just becomes elongated. And maybe you saw that in the vial. One of those vials had elongated bed bugs, meaning they had just fed. So that's exciting. So concerning how long they can live without a blood meal, maybe it's up in the air right now. The old research says that at 50 degrees, which is pretty cold, so it slows down insect metabolism and growth, and almost brings them to a standstill. But anyway, between feedings, they can go for over a year. They're saying at this temperature. So if your strategy is to leave, that's not a good strategy, especially if you have rodent pests or things like that in the home. There are a lot of secondary hosts. Pretty much any mammal or bird that these things can feed on, that can extend their life cycle. So if you leave and you have pests in your house, they might be able to survive still even longer. But here's at 80 degrees. and these numbers are probably more realistic in terms of what we're actually seeing today. But we're looking at a couple months, maybe 3 to 4, 5, 6 months is how long they could live without feeding. In that one publication that I talked about earlier in the talk, there was an asterisk in there that said via personal communication. So this data hasn't been published in a peer-reviewed journal, but somebody at one of the leading research labs for bed bugs said that modern bed bugs die in about 3 months, after feeding, or if they don't feed, they'll die within 3 months. So give or take, but just have respect that if the temperatures are cool, they could live for over a year. Okay. Just some other interesting facts. The average they travel a night to find food is about 20 feet. So if you think you're going to leave your bed and go to the couch, it'll just follow you. And then you'll end up infesting your couch. The longest recorded one so far has been 66 feet. Like I said, this information came from 2007. A person recently did research in a multifamily housing unit in New York, I think it was. And he kind of wanted to track the dispersion of bed bugs from an apartment. So he set up these climb-up interceptors in the rooms, but also out in the hallways of the building. And he found that if populations were high enough in that room, that some of the females would migrate out of the room and walk down the hall and go into the next apartment. So realistically, they can probably travel hundreds of feet to disperse and find new hosts. So you're not going to escape them. They move pretty fast. They can cluster together, but not always. And then here's this one critical aspect, and they have been shown to be able to carry 27 human pathogens, but they've never been shown to actually transmit any of those. So as far as the government's concerned, these things aren't a health risk. Unless you're fed on them, then you have mental problems. So,
Cockroaches aren't either anymore.
what's that?
They're not looking at cockroaches as a disease issue.
Really?
You look at CDC and all they talk about now is allergens.
Oh,
It's the same issue. You can trauma across a petri dish and cultivate all kinds of stuff.
right.
They can't associate specific diseases to it.
Yeah.
Wondering if as far as with the disease, I mean, is there ongoing research to find out why they don't transmit? Is it because they wait long enough between feeding?
For this, the question was, are they actually actively researching why bed bugs don't transmit disease? I think they are looking at it, but they don't have any definitive answers. Why do mosquitoes transmit certain things and bed bugs don't? If you think about parasites in general, I mean, it should be the goal of a parasite to keep your host alive and healthy as possible because, that way your food source stays alive. So maybe through time, they decided it wasn't beneficial to give people pathogens that might kill them because that takes away their host. That's just a theory we came up with about 10 minutes ago. So take it for what it's worth. Okay, so resistance. I think this is a pretty critical issue with bed bugs. I was going to explain it in great detail, but I might not. And so this says right here, will kill bed bugs, but will it really kill bed bugs? And the answer is maybe not so. Do you all know what insect resistance is? You probably do. It's pretty straightforward. But I'll read the definition anyway. It occurs when a population of insects builds up a tolerance to a specific chemical or group of chemicals with the same mode of action. And mode of action basically means how an insecticide kills. So how does that chemical work within the body of the insect to kill it? And so just to explain how this happens at a population level, let's say we have a new population of aphids and they're being exposed to a brand new chemical. Just naturally, within the genetics of the population, you're going to have a few individuals that are resistant to that insecticide. They just have the genetics for it. So if you go out here and you spray this population with an insecticide, you're going to kill, over 90% of those insects. And you think you've done a good job, and you have done a good job, I guess, but some of those things actually remained alive. And they reproduce. So next time the population builds up again, you have a little bit more of the population that has resistant genes. Spray them again, you're selecting again for resistance. Spray them again. So over time, especially in insects that reproduce rapidly, like mites and aphids and maybe even bed bugs, they pass those genes on at a rapid rate. And so resistance can build up over the period of a summer for things like aphids or spider mites, because they have 8 to 12 generations per summer. So they can pass on those genes. On things that only have 1 generation per year, that takes a lot longer to build up this resistance. But regardless, this can happen. And it has happened with bed bugs. The bed bugs have only been around for the last decade. So how have they possibly built up a resistance to insecticides already? The predators? Oh, yeah. I guess I didn't mention that. Good point, Greg. You'll notice at the beginning I have these. This is all original artwork, by the way. Yeah. Took me, you don't even know how long it took to make this slide. Anyway, yeah, these are what immature ladybird beetles look like, ladybugs. And when you go and you spray a broad spectrum insecticide, meaning it's not selective for the pest, it can kill pretty much any insect. When you start spraying those, you kill off these things. And ladybugs, they only have like maybe 2 generations per year. So if you kill off the first generation, the first spray, you have a lot less. You spray again, you pretty much have killed off the population of ladybird beetles. And that, allows this population to grow even more. So in an IPM approach, you would either not use an insecticide, or you would try to use an insecticide that was selective just for aphids and wouldn't kill ladybird beetles. Or you would try to treat when ladybird beetles weren't present, or something like that. You would try to preserve the natural population of beneficial insects to keep the pests under control.
Can you buy those?
Can you buy those? Yeah. You can buy a lot of biological controls like that. Do they work well outside? I don't know. I mean, what do you think happens if you dump a bucket of ladybird beetles on a plant? Right, they just fly away. Well, maybe not. Where things like that really work well are in a greenhouse setting. You kind of have a captive audience, I guess, kind of like you guys. But yeah, so those things work well in an indoor setting. You can also buy the immature forms, and that might take a month or 2 for them to be able to fly away, to develop wings. So the immature form, might be a better way to go. But either way, I forgot what I was talking about. Oh yeah, bedbug resistance. So how is it possible that they're resistant to most of our pyrethroid insecticides today when the populations really haven't been exposed to them? And the answer goes back. You have a question?
I was going to say, some was indicated that probably a lot were resistant to DDT.
Right. So you're right. So when they were spraying this stuff back in the 40s and 50s, as bedbug populations were dying out, they noticed that some of these populations were gaining a tolerance to DDT. So eventually DDT wasn't going to work anymore anyway. So as far as bringing that back as a chemical to use, it's probably not going to be very effective. Anyway, so when we talk about mode of action, people have actually grouped modes of action. There are about 28 modes of action right now as far as chemistries go. And a lot of these products, they work in a similar fashion inside the insect body to kill. And it just so happens that DDT is in the same group of insecticides as pyrethroids in terms of mode of action. And so these are 3B, and this is group 3A. And there's something called cross-resistance. And since they were resistant to DDT back when they were being eliminated, it just so happens that they have cross-resistance to pyrethroids, which are closely related to DDT. And this occurs when a population of insects that has developed resistance to one product exhibits resistance to one or more products they have never encountered. So as these populations came back, they were already resistant to pyrethroids. And, okay, I erased the slides I was going to use to show you how this happens, but basically, the group 3, they're called sodium channel modulators. And so within a nervous system in your body, you have neurons, right? And then, so there's like a neuron cell, and there's this long extension called an axon. And the electrochemical gradients that create nerve impulses, they're controlled by sodium channels. And so what DDT and pyrethrins do is they basically hold those sodium channels open. So you have these sodium ions continually entering the neural axon, and it causes a rapid firing of nerves. And eventually it causes the nerves to just shut down completely. And so that's what you're doing, basically. When you're using a pyrethroid or DDT, you're causing paralysis to the nervous system, and that causes the insect to die. But where DDT works on that sodium channel, pyrethroids work on the exact same spot. So you can see that if you're resistant to DDT, you're also resistant to pyrethroids. Does that make sense? Yeah, I don't know. Maybe that's a bit complex. So here's the situation. The problem with today's insecticides, of course, the government says what we can and can't use indoors, right, for human health. And, fortunately or unfortunately, majority of the insecticides we have to select from are within this pyrethroids group, meaning bedbug populations are resistant to most of them. These pyrethroids, if the pesticide applicator actually sees the bedbugs and directly applies the liquid to them, it kills them. But as soon as it dries, it loses its effectiveness. And it might even act as a repellent, keeping bedbugs away from the area. But once it dries, they've reported bedbugs walking right over that dried substance. It doesn't kill them. So only when it's wet do these pyrethroids work. They have poor residual properties, meaning, again, as soon as it dries, it loses effectiveness. They need to be reapplied multiple times. And quite frankly, the chemical industry hasn't really caught up to bedbugs yet. And they didn't really have any bedbug-specific insecticides before this all started. I'll show you at the very end, there are some new chemistries they're coming out with to deal with bedbugs. But again, there's not going to be any silver bullet. And I went online to search our database. And it's actually free. You can go online and anybody can search this database. But Utah has all the registered insecticides or pesticides in a database. And you can go in there and look for different things. So I went into this database and I searched for all the products that had bed bugs on the label. And I came up with 363 different products. And then I narrowed my search and said, how many of these can be used on mattresses? So directly sprayed on mattresses. 241 products came up. So there are a lot to choose from, right? But then I broke it down further, looking at active ingredients of these 241 products. And pyrethrins, permethrin, deltamethrin, lambda, cyhalothrin, all these things we commonly use, they're all actually types of pyrethroids. So 238 of the 241 were pyrethroid insecticides. So you can see right there that a lot of the tools we have aren't going to do the job. So we have to use an integrated pest management approach to kill bed bugs. If you're going to just spray, you're not going to be successful. So, like I said, you have to use integrated approach. The other thing is that most of the insecticides we have, they don't kill eggs. So you can spray the eggs directly, it may or may not kill them. But if it does, just the fact that most of them don't kill eggs, that means you need a minimum of 2 treatments 2 weeks apart. Multiple formulations of products are more effective. If you're going to go, the insecticide route, don't just use a liquid spray. You have to maybe drill holes in the walls and apply insecticidal dust into the wall voids. You can use insecticidal dusts underneath beds maybe. Or also, in high populations, bed bugs will actually go into electrical outlets and hang out in there. So you take off the face plate and you put insecticidal dust inside there. And then maybe you have areas that have really tiny cracks where the liquids just won't penetrate. So you can use an aerosol formulation, spray can, and that'll penetrate into the cracks. I know this is an IPM talk, and I'm talking a lot about insecticides, but while we like to reduce the use of insecticides as much as possible, they're probably still going to be necessary for bedbug control, is the bottom line. Okay, so again, no silver bullet.